So now that you know how to differentiate things, let us revisit the problem that we initially started with, right? Do you remember the problem was 3t square plus 2, right? So this was the displacement that was given to us with respect to time. So displacement was given with respect to time. What this meant was that at, let's say if I make a table between time and displacement, at t is equal to 0 second, the displacement was 2 meter. At t is equal to 1 square, it was 5 meters. And then at t is equal to 2 seconds, the displacement was 3 for the 12 plus 2, 16 meters. No, 14 meters, and so on, right? You can make the table up to infinite times. But it was finding that velocity was difficult because every time you take a second, the velocity was coming out to be different because the velocity was keeping on increasing. So we wanted to find the velocity at a single point in a very small time interval, so that I can tell people ki acha at this time, at this point in time, the velocity is something like this. Okay, and I wanted a very accurate result because if I take a velocity between 2 and 5 meters, which is 0 second to 1 second, I can say the average velocity is around 3 meter per second because 5 minus 2 is 3 meter and it happened in 1 second. But you understand that this equation is not going to give you, if you take an interval between 0 to 0.5 seconds and 0.5 seconds to 1 second, these will not be 3 meters per second. The velocity will actually be different within 0 to 1 second only. So we decided to increase the accuracy of our measurement, we need to take the time interval as infinitesimally small time interval. For that, we need to take what? Differentiation. So let's find out velocity. Velocity is displacement upon time, right? But if I want to do a variable displacement velocity, if I want to find out the velocity of a variable displacement, I have to use what? Differentiation of displacement with respect to time. This is what we need to do. Okay, differentiation of displacement with respect to time, because our displacement is not increasing in a linear fashion. It's not very easy. It's a variable quantity. So when I need to find out the displacement with respect to time, since it is a variable quantity, we have to use differentiation. Okay, so what is this function? 3t square plus 2. This is the differentiation I have to do. Now if you're comfortable with differentiation, then let's see what we can do here, right? So you'll have to use the addition rule here. I'll differentiate what? 3t square first, and then differentiate 2 with respect to time, right? Now what is the differentiation of 3t square? 3t square is nothing but 3 is constant, so it will come out. Differentiation of t square with respect to t plus, what is the differentiation of any constant number? That was the first formula in the list. It is 0. So this will become 0, 0, right? What is the differentiation of t square? T square is nothing but 3 into 2 times t raised to power 1. So this is the formula I use. Differentiation of x raised to power n is n times x raised to power n minus 1. So that formula is getting used here. So t square will become 2 times t raised to power 2 minus 1. So this is the formula I use. So this becomes 60. So what did I get? What did I get? I got that the velocity at any point is given by 6 times t. So this is how you solve a problem. So now how will you answer this question? So if the question asks you what is the velocity at t is equal to 1 second, what will you do? You know the variable velocity now. Variable velocity is what? 6t, right? So at t is equal to 1 second, what will be the velocity? It will be v is equal to 6 meter per second. At t is equal to 2, what will be the velocity? 12 meter per second. Do you understand? Do you understand? So now for a variable displacement also we can find a variable velocity. That is the ultimate purpose of what? Differential calculus, right? And whenever these relationships, like you might be wondering, sir, how will I know if velocity is differentiation of displacement with respect to time. We will discuss this in kinematics. Every time there is a differential relation, also it will be mentioned in physics. Everywhere there is a differential relationship between two physical quantities, they will mention it to you. Okay, in the differential format, if you want, then the formula for differential format will be like this. For example, I'm giving other examples also, like acceleration is what? Change in velocity upon time. If you remember from earlier classes, acceleration is given by what? Change in velocity, like final velocity minus initial velocity by time period. In the differential format, acceleration can also be given by dv by dt. Differentiation of velocity with respect to time, right? So this will be taught to you in physics, but the math part, I think you should be able to understand from now on. Okay, cool. Okay, now let's discuss about the next mathematical operator that I promised that I'll teach you two mathematical operators, right? One was differentiation, which we just discussed, right? And the next one that we are going to discuss is integration, right? For this, I will use the help of another problem. Same problem, but this time it will be slightly different in the sense that this time the velocity is given. Okay, and I want to find out the displacement. Again, in this scenario, instead of velocity being a constant value, velocity will change continuously, it will change, right? So let me put the problem statement in front of you. Imagine if you have something that is traveling with a constant velocity, right? For example, 20 meter per second, 20 meter per second, 20 meter per second. It keep on going in this direction at a constant velocity. So if I ask you at the end of 10 seconds, what is the distance traveled? How will you say? Very, very simple. You will say distance is equal to speed into time. So speed is 20 meter per second and 10 meters, so 200 meters. No doubt in this. This is 100% correct. There is no doubt in this because the velocity is simply constant, right? But let us take a velocity which is changing, right? Every second the velocity is changing. Okay, so the example here is 50 minus 10t squared. Okay, so let me see how this works. 50 minus 10t squared. Okay, so if I make a table for this for you to understand, and then I put t in the first column and velocity in the second column. So what is the velocity of the particle at 0 second? It is 50 minus 10 times 0 square, which is nothing but what? 50 meter per second only, right? At t is equal to 1 second, find out, it will be 40 second. How 40 second? 50 minus 10 times 1 square, because in place of t I will be putting 1, so 5 minus 10 is how much? 40. Similarly, I can find out for 2. For 2 it will be 10 meter per second. So how will we deal with this kind of a problem? Because if I want to find out the displacement from, let's say, at the end of 2 seconds, how much has the body traveled? If I want to find out, one approach would be saying ki, sir, between 1 second and 0 second, the average velocity is around 45, because initially it was 50, then it became 40. So maybe the average velocity in between them is how much? 45. So I will say 45 meter per second into 1 second. So 45 meters probably, right? And let's similarly do this for the other one. From 1 to 2 seconds, the average velocity will be how much? 25 meter per second, because we just found out. That the final at 1 second the velocity was 40 meter per second, and at 2 seconds the velocity is 10 meter per second. So maybe the average velocity is how much? 40 plus 10 by 2. Average velocity I'm talking. So maybe 25 meter per second, right? Maybe the average velocity during 1 second to 2 seconds is how much? 50 by 2, 25 meter per second. So you will say that during like this was the displacement from 0 to 1 second, and from 1 second to 2 second the displacement was how much? 25 meter per second into 1 second is 25 meters, right? And then you answer the question like this. Okay, sir, then the total distance traveled by this body is probably 70 meters. But the question here is what? Is the answer accurate? Is the answer correct? The answer is no. It is not 100% correct, because from 1 second, from 0 second to 1 second, you have assumed that the body is traveling constantly with how much? 25 meter per second, because we don't have a formula for variable velocity yet, right? We only know ki to find out distance, you have to multiply velocity with time, speed with time. When you multiply, then only you get the distance. No, that is the only formula we know. So we cannot, like, because the velocity is changing at every second, we have to take some kind of an average, and that is increasing the error in our answer. How will I reduce the error? That is the next logical step. I want to reduce the error in my answer. So what will I do? I can take the time intervals to be slightly smaller, right? I can take it from 0 to 0.5 seconds. Maybe the average velocity is 48.75. So the distance is 24.375. And similarly, I did this same math for every half a second. Instead of 1 second interval, I took half-second interval, right? So the error will slightly decrease. If you do the same calculation, I did this a calculation using a calculator, obviously, right? So the distance was slightly better. Now the distance has come out to be 72.5 meters. At the end of 2 seconds, if I take half interval, and in the half intervals, I take the average velocity and then multiply with half second, then I get the total distance to be 72.5 meters. So this is slightly more accurate than the previous answer, but it is still not accurate, because in from 0 to half a second, you have still assumed the velocity is constant at how much? At 48.75 meter per second. Okay, so you have still assumed something, that in this portion the velocity is constant, but the honest thing is what? That the velocity is never constant. It is changing at every millisecond. It is changing because it is a function of time. Okay, so if I show you my blackboard, this is the velocities equation. The velocity is getting is given by 50 minus 10 t square. So that means every millisecond change, 1 second and 1.0001 second also, the velocities are not constant. It is changing. It is different, right? So that's why we have to employ what? To find out the distance, you need to use the help of the new mathematical operator called the integration, right? So if I show you in terms of graph, you can see it like this. Like, it's a very hard problem, which is a sum of very small values. So what we have to do conceptually is to break down the time intervals into very small intervals. So it should be so small that if we assume that in that small interval that velocity is constant, our accuracy should be still correct, right? So that's why we have to essentially make this an addition of very small terms, and this is what? Integration. Integration is making the intervals very small and then adding up the small intervals. Okay, that is the main understanding behind integration. Okay, cool. Now that you know why we need integration, let's focus on how to do this integration. Okay, so just like differentiation, there are a bunch of formulas which are written here, right? So these are the formulas that you need to note down, right? Pause the video and note down the video, note down the formulas. Then I'll show you how to do them in with actual questions. I'll show you how this has to be done. Okay. So write this down, pause this video, and let's move on to the actual questions. Okay. Okay. Let's do one question. Integration of x raised to power 5 dx. How will you do this integration? So the formula was x raised to power 5 plus 1 divided by 5 plus 1. So this is x raised to power 6 by 6 plus some random constant. Remember, when you do integration, there will always be a random constant that will be generated. Okay, to find out the value of this constant, you have to in the question there will be some additional data that will be given. So you'll have to use that. Don't worry about this c, just write c at the end of any integration. Whenever you see a indefinite integration without any numbers, just write a c, because this is like this c is there to compensate for any extra numbers that might be generated during the integration. Okay, let's say I want to do the integration of sin x. So by formula, the integration of sin x would be minus cos x. Okay, integration of 1 by x dx will be what? Log x. Direct formulas, these are direct formulas. Integration formulas are slightly easier than differentiation, right? So you have less formulas to remember. Okay, one more thing that you can notice is that differentiation and integration are like complementary functions of each other, just like plus and minus. Okay, so imagine if you differentiate d by dx of sin x, you get cos x, right? So whatever you get on the result, if you integrate again, so integration of cos x therefore will be what? Sin x. This is what I'm saying by when I say it means complementary. If you differentiate a function a to get b, then integration of b with respect to x would give you a. That is what I was saying, right? So if you remember the differentiation formulas, the RH, you just have to convert the RHS to the LHS and LHS to the RHS. Change that, and then the formula for integration would be same as the formula for this differentiation. You just have to reverse the the left hand side with the right hand side. Okay, so that is one way of remembering the integration formulas. Cool. Okay, now I want to tell you how to do integration with a definite interval, right? For example, in our problem was what? 50 minus t square, you have to integrate, right, with respect to time only, because the variable is time, so I'm integrating with respect to time. But this time it's not a random integration problem. I'm integrating from 0 seconds to 2 seconds, right? To find out the displacement when I do the integration, I cannot do a random integration. It will just give me the value of displacement in a variable form. What will I do with the variable form? I need at the end of 2 seconds, how much has the body traveled? That was the initial question. I need to be able to answer that, right? So what will I do? I'm going to highlight this here. You'll do the same integration only, 5 minus t square integration only you will do with respect to time, but you will put the limits also, like from where to where, like 0 seconds in the bottom, 0 seconds to 2 seconds. Okay, so this is something new. I'm going to tell you how to solve this. So from here, first do the integration as it is. Okay, so first integration of 0 to 250 dt. Again, the addition rule is valid here also. I didn't specifically tell you, but if you have like a plus b and you have to integrate the whole of this, you can first integrate a and then add integration of b later on. Okay, so that is pretty easy, so I didn't mention it. So from here, subtract 0 to 2 integration of t square dt, right? So integration of a constant is not 0. Okay, differentiation of a constant was 0. Don't say this is 0. This is not 0. This is what? Let me think about this. Okay, so 50 is a constant. It is going to come outside of the integration, so 50 times. Can I say this is t raised to power 0? Why can I say this is t raised to power 0? Because t raised to power 0 is what? 1. Right, now use the formula. The integration of x raised to power n with respect to x is how much? X raised to power n plus 1 upon n plus 1. So if I want to do the integration of t raised to power 0 with respect to time, then this will be simply t raised to power 0 plus 1 divided by 0 plus 1. So this is what? T only. So integration of 1 is the variable itself, right? So 50 is a constant, so it came out of the integration, right? And after that, t raised to power 0 remains inside the integration, so this becomes 50t. The first term is simply 50t, right? The second term will become how much? It will become t cube by 3, t raised to power 3 by 3. Okay, and remember, I have still not plugged in the values of 0 and 2. Okay, So what I have to do is write something like this, minus 3, and then in brackets, again, we still haven't put the limits, okay? So this is how we write. We still haven't put the values, okay? Now, how do you put the values? This is the simple integration. Up to here, this is simple integration. 50 is integration is 50 times t. T squares integration is simply t cube by 3. Okay. So how do I plug in this 2 second and 0 second? It's simple. First plug in 2. So in place of t, I'll be putting 2. Okay. 50 times 2 minus 2 cube by 3. I plugged in 2. Right. After that, what do? I plug in 0. So 50 times 0 minus 0 cube by 3. This is the formula for this. And also remember, you have to subtract. Okay. First plug in the upper limit in the numbers, and then plug in the second limit in the numbers, and then subtract them. So when you solve this, this will become 100 minus, how much is 2 cube? 2 cube is 8 by 3. And this is to 0 only. 50 times 0 minus 0 cube 0 is simply 0. So this will give me how much? How much is 8 divided by 3? So this is 100 minus 3 2s are 6, almost 2.6. So this is around, roughly around 97.4 meters. So do you remember the question? In 2 seconds, how much the body has traveled? The correct answer is how much? 97.4 meters. This is 100% accurate. This is 100% accurate. If you do a variable question using integration, your answer will have no error. But if you take finite intervals like 0 to 1 second, 1 to 2 seconds, there will always be error. Remember, your answer was coming around 70 meters. The body had actually traveled 97.4. But if you do in average velocity terms, like if you break into intervals of 1 second or half a second or 0.25 seconds also, you'll still have so much error. So if you want a correct answer, you have to use integration in such situations. Again, you might be asking, sir, how will I know that I have to do integration? In physics, everywhere integration is applicable, we'll tell you here integration will be useful. Here integration will be useful. Okay. Let's do some more questions, because I feel like with just one question, the way you do the integration will not be clear. So let me make up some questions for you. Okay, so let us do 0 to let's say 1 to 2 5x dx. This is slightly easier than that. So you do it on your own and then check your answer. Okay, so the solution for this, I'm doing this. So first I have to do simple integration only. So 5 times x, 5 is a constant. I'm going to bring it out of the integration. It has nothing to do with the integration. So 5 integration of 1 to 2 x dx. Right. So x raised to power 1, I can consider this x raised to power 1. So when I integrate this, this will become x square by 2, right? And I have to plug in how much? 2 and 1. Still haven't plugged in 2 and 1. So how will I plug in? First, I will put 2 in place of x. So 5 times 5 is as it is. I'm going to do this operation inside this curly bracket. So 2 square by 2. I plugged in 2. Okay. Now I'm going to plug in what? 1. I'm going to plug in 1. So this is 1 square by 2, right? And then put a minus sign in between. So 4 by 2 minus 1 by 2, this becomes 3 by 2. So this becomes 5 times 3 by 2. The answer is 15 by 2. Okay. This is the answer. Let's do two more questions. Let's do integration of, let's do slightly difficult, x cube 3x cube plus 4x4. Actually, let's make this 4, let's make this 5, and let's integrate this from 0 to 1. Okay, calculation wise, I'm making this simple, right? I just want you to understand the basic procedure of doing this. Putting numbers like 100, 200, it will just increase the complexity in terms of calculation. It will not change the underlying concepts, right? So that's why I'm just taking 1, 2, 0, 1, because I want the calculations to seem easy, right? But later on, you might have to do integration between, I don't know, 50 and 60. In those cases, the concept will remain same only, but the calculation will become slightly harder. Okay. So again, to do this integration, first I'll integrate this part, right? So 4 times x cube, if I want to integrate with respect to x, 0 to 1, right? So 4 is constant only, I'll bring outside, plus again 0 to 1, 5x4. Should not just leave it here. Let's do it completely. Now let's do this. Okay. So integration of 4x cube, 0 to 1. So 4 as it is, integration of x cube will become x4 by 4. So this 4 will cancel out with this 4. All I need to do is plug in 0 and 1. Okay. So if I want to plug in 1, this will be what? 1 raised to power 4 minus 0 raised to power 4. This is what I did, right? Let me zoom out a little bit. And if I want to do the integration for this, this will become 5 times x raised to power 4 plus 1 is 5 divided by 5. So 5 and 5 cancel out. Okay. And I still have to plug in what? 1 and 0. There is a plus in between. So this is plus, right? So 1 raised to power 5 minus 0 raised to power 5. Okay. So this becomes 1 plus 1, which is 2. So the integration for that whole thing is just simply 2. Also remember, whatever we learned in x doesn't have to be in x. What if I am trying to integrate m raised to power, sine m? Sorry, I'm only taking x raised to power something. Let's take sine m, or let's say sine theta, and we are integrating with respect to theta. Theta is the variable. Integration of sine theta with respect to theta, and this time the limits will be 0 to pi by 2, 90 degree. This is radian form of the angle, 0 to pi by 2. Okay. So what is the integration of sine theta with respect to theta? It will be simply minus cos theta. Okay, minus cos theta. And then I'll plug in the values of 0 and pi by 2. So when I plug in what? Pi by 2, this will become minus of cos pi by 2, right? And then I'll plug in 0 now, minus of cos 0, and then I'll put a minus in between. Okay. So this becomes 0 minus minus 1. So this is plus 1. So you understand what the signs are happening. Just take a few moments to realize what is happening. Okay. Okay. So this is how you do integration. Let's go back. Let's see. Okay. So this is the thing that I was explaining, right? If you have an integration that you are doing from A to B, and you do the integration and you get some gx, right? First you plug in the value of upper limit in that gb, and then you plug in the lower limit in that becoming ga, and then you subtract in between. So that's how we do the integration when our limits are defined. These kind of integrations are known as definite integral, because you know from where to where you are doing the integration. But if you are not given limit, you just need to integrate and put a plus p at the end. That's it. But if you have definite numbers, then you'll get a definite answer also, right? You don't need to add plus p at the end. Okay. So that is the logic. Okay. So here I'll upload these questions as assignments along with this video. You can find out, there's a bunch of questions that you can practice from here. The solutions will be uploaded, and I highly recommend that before starting the physics classes, you need to be comfortable with basic differentiation, basic integration, and the coordinate geometry and trigonometric functions. Okay. So this much that I have taught in the basic module, that part too you should be very, very comfortable with. Okay. And that is the end of this lecture. I'll see you in the next session.